welcome back to the education track. It is backwards. There we go. Do you want to swap it?
Mm-hmm.
I will. It is my absolute pleasure to introduce Renee Noble. She is a senior cloud advocate at Microsoft. She is also a wearer of just so many hats. The Girls Programming Network, tech inclusion, just way too many things. Fabulous shout out before from Kookaberry work, connected code. If I kept on with the intro, we would run out of time. So in the interests of actually hearing what you have to say, Renee, take it away.
Excellent. Fantastic. Lovely to be here today. I'm going to talk about how smart AI really is and have a real-world project to help build real-world understandings for you or your students or whoever you want to give this out to. But yes, we've just gone over vaguely who I am. Basically, I'm some sort of conflux of tech, education, and community. I do work for Microsoft. I'm in the Python Cloud Advocacy team, and I get to do cool things like this and make cool samples like the one I'm going to show you, or make blogs and live streams and go to events and help make the world easier in terms of technology and becoming a developer and using those skills. I also get to do cool stuff as the CEO of Tech Inclusion and the Girls Programming Network, and also my side business, which I run with my lovely husband Jack, Connected Code. We work with the Kookaberry team sometimes and do other cool stuff helping teachers teach the digital technologies curriculum in schools. So altogether, those are all about context-driven learning experiences. That's a really great way to get people to get students to engage with tech education. Like, why are we doing this? So I'm going to talk a little bit about that today in the context of AI. Have you heard of it? You might have heard of it sometime in the last couple of years. If you haven't, you might have been living under a rock. We can probably help you out a little bit today to catch you up. So what is AI? It's artificial intelligence. Great, we can probably go now. We know what the words are. We probably need to go a little bit more into what AI is and why AI is. But it starts a lot further back than we might actually think. So we're like, yeah, cool, ChatGPT's been around for like 2 years and 1 month now. So yeah, we've got heaps of AI experience. Actually, we're going to go way back to the 20s and the 30s and 40s when we first start thinking about AI. So we have, right then we have the hypothesizing around theoretical artificial neurons. We're going, yeah, brains, they learn things, and you have some inputs and output, and you kind of like, if you think about your own thinking processes, we have some like different inputs coming in, and then we're like, yeah, and this is how it comes out, and you can balance those different inputs in your mind when you're making up a decision. So at the very simplest form, we have this artificial neuron concept where we have, in this example, 3 different inputs, and then we work out the weights for those because we know what the inputs are, we know what the outputs are, and we can back calculate essentially what those different weights are for when we're training, getting this neuron to learn how to predict a future output based on some new inputs. So we start with that, but we're not doing it yet, we're just thinking about it. But come 1950s, we are starting to do it. In 1951, we have the first checkers and chess bot. So we're describing these games mathematically and putting them into a collection of those artificial neurons now called a neural net. So we've got a couple of those, and we can shove together a bunch of these different circles and inputs and outputs and different weights on the different arrows we've got going on there. And we can start having things that seem like they're making decisions based on the best outcomes of the game. So we're going to use this a lot throughout the rest of this history. We're going to have to breeze through a lot of the history because there's been a lot of stuff happening in the world of AI and machine learning since, especially like the 1950s when it really kicked off. In 1955, we start thinking about not just numbers, like games you can describe in numbers. There's a chessboard, it's got spots on the grid, but we start thinking about like, how can we put symbols, maybe words or like mathematical ideas into these numbers, like proving different mathematical formulas, and we start thinking about those concepts, and that's actually when the word artificial intelligence was coined, or AI, and at around the same time, based on the mathematical principles and the neural nets we've had with our chess and checkers boards, we get machine learning coined at the same time. So these are kind of 2 concepts that kind of entwine together throughout history, and it's kind of still, it's never quite clear what the difference is and what the similarities are. And that, maybe changes depending on exactly what context you're in, but they're really both quite similar things. And when we kind of understand that, we really understand it really all comes back to the maths behind the machine learning, these diagrams we're looking at that will continue to go on throughout our history of AI now. So we keep going with this idea of these neural nets, and we're starting to think about language now, natural language, that is, like, how can we speak to something in English and have a computer talk back to us? And in 1966, we have the creation of the ELIZA chatbot, which today, if you're talking to ChatGPT, it seems very, very, very basic. Even if you have a kid today who's barely ever touched a computer, try and talk to ELIZA, they're probably going to work out that this is not really a computer that can think. It's a pre-canned answer, it's going to give you back things, and it's very easy to quickly get it to loop and tell you the same thing over and over again. But at the time, this was like the first thing that we have had that can do something like that. So it was actually quite revolutionary at the time, and we're still talking about it today. So we're actually going to jump way forward to the 2000s, because there was stuff that happened in the middle there. We tried a few different other things. We did things that weren't related to what we're going to talk about today is GPT technology. But yeah, and there were some ups and downs. We kind of didn't have enough big computers. We're really good at big computers now. So as we get into the 2000s, we start working on probabilistic AI. If you've ever played with a Markov chain, this is it kind of gives you the idea of where we're getting into these things that start to have things that look like language. So we have probabilistic AI, and Markov chains might be like, I've got all the lyrics to different Taylor Swift songs, and I can now predict a new Taylor Swift song based on a couple of starting words, potentially. So we've got those ideas coming into play. Then jumping into the 2010s, we've got big data and deep learning starting to happen because we have a lot more computational power out there. We've got cloud computing happening. We get the creation of DeepMind in 2010 and OpenAI, you might have heard of that one, in 2015. And finally, ChatGPT launched in 2022. And it's been a little bit weird since then. It's been kind of a really different tech landscape and education landscape since that came onto the scene. So where are we today? We have all this great technology, and we also have a thing that if we ask AI, if you ask ChatGPT how many R's in the word strawberry, it's going to tell you strawberry has 2 R's in it. So what does that mean? I'm actually kind of okay with this because that's kind of not its job. People are like, it's not actually very smart. I'm like, that's correct. It's not smart. It's not a counting machine. What we have with GPT technology is something that can predict the next sentence, predict the next word. It's great at guessing things that look like real sentences, real documents, which is really handy. But what its job is not is to do maths. So you're asking it to do something that it's not trained for. And even if you had a child prodigy who was 8 years old and they're going off to Juilliard to study the piano, you're still not going to ask them to do your taxes. So we've got a conflict of what we're asking GPT technology to do and what it's actually designed to be really good at. So where are we today? We've got our GPT technology. That means generative pre-trained transformers. People are like, GPT, yeah, that's that brand name for ChatGPT, but it's actually this concept. And in this realm, we have a couple of things. LLMs, you might have heard of them, large language models. There, we've got a bunch of words, and we've shoved them into some deep learning. Some of those neural networks, we saw the diagram with a few circles on it before. Now just imagine just millions and millions of circles and lots of different layers and lots of different arrows. And now you're starting to imagine a fraction of the networking that you need to have this kind of idea that's bringing all these words together and having something come out on the other end. We also have slightly smaller versions of that, SLMs, small language models. These can actually be really cool. You might think smaller isn't as good as bigger. That's what we've learned throughout history. We needed bigger computers to do more AI. But now we can think about if we put in a more selected section of texts, we can actually predict things that will be more specific to your use cases. And it will be faster because making a really, really big network means you have to spend a lot of time traversing that network and doing all those calculations. So super handy, and they're super good for this educational landscape as well, because we have kids with their limited patience for waiting for AI to give them back a response. So we have a bunch of different models in these realms, because we've heard about ChatGPT, but we also have we've got different things coming out from Meta. We've got different open source options. So there's a lot of models out there. So we can choose the ones that are best for our use cases and then have a good, fun time with them. But how do we actually go about teaching and using AI responsibly? Now that we know that AI isn't smart, we had the whole strawberry situation going on there. How do we make sure we use it correctly? Well, we need to judge the correct context, and we need to teach our students to do the same thing. So there are a few things that AI is good at. Generating highly standard text. So things that I don't want to do is write a whole work health and safety policy. There's a lot of those out there. There's like millions of those. And I'm not that special. I don't have that many brilliant ideas around it. So it's actually really convenient to say, hey, ChatGPT, I have a charity, Tech Inclusion, that we need a policy for work health and safety, and we work with children. So it can be like, oh, cool, I've read a bunch of those. I can give you one of those back. And then my job is to be the supervisor to that, to make sure, hey, this is relevant to my purposes, and I also need to go and add some things that I, as a person who actually goes and does Girls Programming Network, would actually know that the policy needs to include. So you can't trust it, you can't rely on it, you can't ask it to do all that work because it's not there, it's not in your organization, but it can be like, I've seen a thing like this before, here's some tips on how I would write a generalized the average of a work health and safety document, given you've asked for one that's like a bit more child appropriate or things like that. So that's one thing you could use it for. You could also use it for proofing your own work, because it can also, if you're like, yeah, I like what I've written, except I want it to sound more fun. It's been like, I've read fun things on the internet. I can help you be more fun with the power of algorithms. So it can help you do that. And also, the only thing is, when you're doing any of these things, you do need to make sure it matches your purposes. So you could ask it to be more fun, but maybe it's fun in the wrong way. Or something that I like to think about, specifically if I'm generating code, because that is a really standardized format of information, but there's a lot of different standardized ways of doing it. So for instance, I might be, for Girls Programming Network, wanting to create some code that teaches the kids how to make a scissors, paper, rock game. Pretty basic game, but there's a lot of ways you could code that. So I could be like, using GitHub Copilot, great, love to use it, because I hate, having to write things out. I'm like, I already know what I want to write out, but now I have to do the finger moving to make it actually be on the page, and I'm going to make a bunch of typos in the process of doing that. So instead, GitHub Copilot can be like, yes, I know what you're trying to write on that line. Here you go. I'm like, great, I don't need to write that line. That's exactly what I would have written. Now it's done. But if I do give a generalized prompt like, make scissors, paper, rock for me, and it will be like, great, I've seen a lot of those online, here's your code. I'm like, that's some good code right there. But also, this is for year 7, and that has some objects, it's got a list comprehension, it's got a dictionary, it's got this, that, and the other. I'm like, the code's not wrong, but it's not right for my purposes. So making sure that you go through, and whatever you're generating, making sure that whatever it's given you is what you need. So, other things to watch out for are, once again, reflecting on what it's designed for. So it's great at making text that looks correct. That is definitely a sentence that belongs in a document. It's definitely in English. The spelling's all right, and things like that. That's great, but it doesn't necessarily make things that are factually correct. And things like references can in fact be made up. They'll look like a real reference, and there have been legal cases where people have submitted documents to court based on ChatGPT, and it's like, actually, this case that you're relying on for the precedent for the legal case doesn't exist, and it's been made up, and they've been in a lot of trouble. So don't get yourself into trouble like that, because you need to remember that ChatGPT kind of things, generative technology, generative AI can only remix content that it's already seen. So it can't do any critical thinking around that because it doesn't think, can't think about strawberries and the spelling of that. So don't imagine it can be like, is this better to include or that better to include on like a moral or intellectual level? It's just going to take the average, essentially, of what it's already ingested. And then it's not going to make anything creative on you. If you want to bring something new into this world, it's definitely not going to be done with generative AI. You need to bring the creativity. And it could be a tool in your process, but you do need to bring that in there. So now hopefully we understand a bit that generative AI is not magic. How can we take the magic away from the children? So we can see what AI is actually like under the hood by kind of stripping away a lot of the stuff around ChatGPT, which is probably what they're playing with most of the time, because that has a lot of stuff about making sure the conversation remembers what it said before and having all these extra bits and pieces that make it feel smarter than it is. We can also work out how easy it is to manipulate AI and also see how adding our own data can change the responses and kind of maybe give it some motive to do something that isn't necessarily the base level ChatGPT experience, making it trying to sell you something, for instance. So I've got a project to do all of that. So it's going to involve connecting to an AI model. We're going to be using GitHub models, and it's going to be free, which is great. We're going to be using the AI API to make a call to that model. And then it's also a great opportunity to practice some Python there with your students and get some of those core year 7 to 10 concepts going in there, which is great. And then also we're going to add some data to that and give it that motive to sell, sell, sell. So if you want to grab this repo, there is a link there. It's also going to be sprinkled on a few of the other slides. And then, yeah, it's all going to be in there. These slides will be on there at some point, just having a little bit of Git trouble to getting them to upload. Okay, so before we get started, let's be prepared. Firstly, you can grab my repo. There's the link again. It's got the template, and you can use it however you want. You can just be like, here, class, you can play with this. Or you can be like, I want to make an experience of this. I'm going to use it for 10 hours of material. I'm going to take out all the Python, and then you're going to have to write it yourself. You can do whatever you want. So be prepared with that. Consider the school rules of your school. So you might have a policy around AI at your school. Also, you might have firewalls around AI at your school. So before you go, this is what I'm going to do tomorrow in class, make sure you check those out. Be secure. We're going to be using a secret token as part of this. Never share your credentials online or with other people. And it's bad cybersecurity. And then we also want to consider the content policy and your class. So each of these models, especially the ones on GitHub models, have some sort of content policy that prohibits use of bad language, that prevents people asking how do I bully my sister, things like that. So make sure that the restrictions on the model that you're saying we're going to use in class is going to be appropriate for the level of your class. By just giving it a play and being like, what would be the first 10 things a student asks this model? It's a good way to kind of figure it out. And then finally, we've got classroom management. All your problems with plagiarism, bullying, and child safety can be on steroids when you introduce AI to the classroom. Well, we already know that the kids are already doing all this stuff. So think about how that's going to go in the classroom and do have a conversation around proper use of AI socially within the context of that. So now we're prepared and we're responsible. We're ready to play with Python and do cool stuff. So the first thing we need to do is get some AI, which is we're going to go to GitHub models. We're going to grab ourselves a personal access token, and we're going to grab that and put it into our Python project. So cool, we've got the marketplace here where we can go in, we can say, oh cool, there's a couple of AI models even listed on the front here. We're actually going to use a couple examples in here, but the GPT-4o Mini is good. It's one of those small language models. Or we've also got the 5.3 Mini, which you can get that one and actually install it locally, which is really handy if you don't want to do it on the web and you want to run it all locally within your classroom. So we get that. We can play around in the playground. Maybe you want to let the kids do that and go wild, or maybe you want to do that as a demonstration on the board. You'll know that based on your own classroom and your own kids, and see how we can have a play there. So we've got a few going on there. The things in the right-hand side, we can set different things there, like the system prompt. Some of the models don't interact well with the system prompt in there for some reason at the moment, but some of them do. But we will be changing the system prompt in our code in a second, which we can do once we get our personal access token. So we're going to go in here, we're going to go and get developer key, and it's super simple to do it. You can go and you're going to make a classic style key, give it a note to say what it's for. Next up, we're also going to be selecting the expiration. For cybersecurity reasons, always choose the minimum you require. Don't be like, I don't know when I'm going to want to use it again. I'm just going to make it go forever. Think about being secure and reducing what you need the token for. And you don't need to tick any of the boxes you just saw on the screen. You scroll to the bottom and say, yes, I'm done. And then you're going to grab this token. You're going to grab it now because otherwise you're never going to see it again. You have to go to make a new token because you can't just look it up again. Cool, we've got our token. Now we're ready to do some cool stuff. If you can't do that process for some reason or another, maybe you can't access GitHub or something like that from your school computers, you can go and download Ollama, which is an open source way to interact with AI, and then you can use these different models by installing them locally. Okay, cool. Now we have our token. We're ready to use the template. So firstly, we're going to put our token into the .env file. This is the file we're not going to commit because it has our secret token in it. Yes. Okay, we can run pip install for the requirements to just get the few requirements we need, which is mostly something to get the token out of the env file, and then the thing to get all the AI, which is cool. So we can do that. If you also want to use this and not have to do any of that, you can run this in code spaces, which is like in GitHub, you can say make a code space, and then you can run it all in the browser, and it will actually install that for you. So you don't have to worry about that. So then we can have a look at the Jupyter Notebook, and this is kind of the main part of the thing. So it's got a workshop essentially, but I've given you all the answers because you're the teachers and you get to know what's going on, and you can go through and be like, yes, I'm going to give this to the kids and let them play with it as is, or you can be like, yes, and that's 5 different lessons of 5 different cells of Python that they're going to work on, and you're going to take it all out and then make your own template and have the kids use that. That's completely up to you and how you want to use this resource. And if you do want to see all the answers, there is some of the code, the full code in the Py file, so you can this is how it all goes together if I didn't have it all in these different cells. But the Jupyter Notebook is great for using in class and just running and kind of isolating those different concepts so you can learn one at a time. Okay, so now we've done that, we can start actually using the AI, which is going to be a bit of fun. We can see here we've got some code that we actually would have seen something quite like it when we were going through the GitHub Models interface. And I've just stripped it down so it looks like a little bit friendlier for the kids. And all you need to do is run this code, and this is going to create the entity, the client, as we call it, that you can interact with to do some chat completion for the next bit of a sentence or conversation that you're doing. So you can hit run in Jupyter Notebooks. If you haven't used it before, you do need to run the boxes in order. So if you ever need to run all of them, all the ones above it, you can hit the play up arrow one on the right to get them all to run to get down to where you currently are. So we've got that. And we can see now we've got a helpful chat bot in our next cell. So this is the code that actually runs and calls the AI. So we set the system message, and this is basically where we tell the AI, this is how you behave. It's you're a helpful chatbot who answers questions, and you can give sources for your information. That's pretty handy. And we've got a question in there from the user. We stitched those together in a list of messages, which you can build up over time if you want to have a more context-aware conversation that remembers more than the last thing that you said. And then on the last part here, we're asking it to say, hey, can you complete this model here? Grab that client that we made earlier, and I want you to complete this next sentence, which is probably going to be an answer to the question, what is the capital of France? So we've got that. We've got a couple of other things in here. We've got the model in here, so we saw that there were different models available online. So you can change the name here. If you decide you want to do a different model, just change this name, and that's as easy as it is to switch it over. And the temperature is also something fun to play with. That's how random it is. If you think about 1, that's the most random, and 0 is I'm always very the same. So we've got different options to play with there. Finally, we get the answer, and we can print it out. So that's pretty fun to just run off the bat and you change the question. But what is the most fun is to see how you can make this behave differently by giving it a different system prompt. And the kids are going to love that. So instead, you might make it a gnarly chatbot. I'd love to do this one. So we say, you're a surfer dude who always keeps it cool. When I say, where should I go on holiday? It'll tell me that if I want to, depends on my kind of vibes. If you're into catching some gnarly waves, I'd hit up places like Hawaii, Bali, or the Gold Coast. So it's pretty chill there. It's got some chill emojis going on. I could also make it pretty rude. You're a rude chatbot who hates helping. Seriously, can't you just pick somewhere? Maybe just flip a coin or something. It's not that hard. So students are going to have a great time with that. So hopefully getting buy-in for this project is going to be pretty easy. And you can also, of course, change the questions and play with that temperature as well. So once we've had a little bit of a play with that, we're invested in the AI now. We can play with Python a bit. And there's a lot of ways that we can just introduce that into what we had with that basic code there. So for instance, we might say, hey, I'm going to answer one question at the moment. What if we added a while true loop and it can keep going forever? We could, instead of having it answer the same question, we could have it ask the user a question, which would be a lot better. So, not always what is the capital of France, you might remember eventually. And then we can build those up all of the time by using append to a list. So we've got a few different concepts going on there. We could also add some if statements, for instance. We could add an if statement, say, if the user says goodbye to end the program, or we could say, give it an option for what kind of system voice you want and have an if statement for like happy or angry, things like that. So we've got some places to play with stuff now. We've also got some data we can play with, because like, what if we don't want it to just only know about what it's been pre-trained on? We want to actually introduce our own data, and we use a pattern called RAG, Retrieval Augmented Generation, for that, which I'll show you about in a second. But it's actually really easy to get started with this. So firstly, when you're adding a RAG pattern, you probably want to change your system message to say you must always use this data or always reference the data that you are providing, because it does have not conflicting but complementary, hopefully, pieces of data there. So in this example, I'm going to say, am I going to make a dessert this time? But I'm also going to provide data that says the best dessert is lemon meringue pie. Chocolate cake is the second best. So I'm going to see how it goes when I ask it for my best dessert recipe. So to add this data, you might be like, how am I adding the data to this model? It's actually really easy. So we had the user question before, content user question, but also we're just going to add, just like string concatenate in the sources and the data. You literally just stick it right in there, and now it has all the information it needs about your data. So here we go. It is giving us a lemon meringue pie recipe, which is pretty good, because that's my favorite. And we know it's the best. However, if you do change the question to be like, I'm allergic to lemon, but you're also providing the data about lemon meringue pie, it will thankfully say the second best option and not give you a lemon meringue pie. It's going to say you should make this chocolate cake recipe instead. So RAG looks a little bit like, well, this is the design pattern. So we've got our search component first. So we ask a question to the search, and then it's going to grab some data from wherever you're storing your data. Maybe it's a database, maybe it's a collection of PDFs, and then it's going to take out some sort of string format of that, and then you're going to stick that into your AI question asking system, just like we had initially. So we've got our question and our data going into there, and our answer being generated. So you can use a bunch of different options for search. You might use a keyword search, and it could search for your PDFs or web pages potentially. Or you might want to use something that is a bit cooler, vector search, which is using natural language processing, defining different words and ideas in a many-dimensional space where you can group things together. And it helps you get fuzzy matching. So in this example, we've got an example about searching for thrash rock, and then we can see that thrash nor rock is in the name Metallica, but you will be able to find it there. So to start using this, we want to build our own RAG AI chatbot. We're going to do it for a pet shop. We've got a bunch of pet shop items and data. We've got a name for each of them and a description. So now I'm going to set the system message again to say, hey, you need to always mention the name of the pet shop. You're going to say they're the cheapest place. We've made that up. And you really want to sell these products. And don't forget to put down your competitors while you're at it. So we're adding that data in here. We're going to create our own search algorithm for this one. You might want to use one of the good ones that's out there, but instead you can make one in class. We're going to make it by finding useful keywords from our question. So here's an example. I got to get a question. I want a scratching post for my large cat. I'm going to get rid of the stop words, ones that I use so often that they don't provide useful information. I see scratching post, large cat, and I'm going to give that from my question is going to be like, okay, if I had purple cat scratching post with catnip, that would have 3 overlapping words with the question. So we give it 3 points. We do that for all the products, and we're going to choose the best 3, and then smush those all together into one big long string of like, this is the data now. So once again, we can just shove that data right into the question, and we've got a data function to get the search results there. And then we see that we actually get a pretty good match. And don't forget, it is going to say always that we're the cheapest, that we want healthy cat food as our question, and don't forget to say that we're better than the competitors. So we've done that, which is great. And if you finish that, that's really great. You can make this into a web app, you can deploy it to the cloud, or you could use real search tools like Azure Search, which are actually, a lot better than this algorithm that we've done there. That doesn't always work so well if you don't have a large data set, or it's not always great if your keywords are needing to be fuzzy matched. So if you're like, but it still seems magic, always remember, it always comes back to the maths, and the maths is based on the information we've got on the internet. How did it become rude? Well, we could easily see that the internet is full of rude people, also lovely people, also people calling other people out. So we have a really good way to train a thing that predicts what rude people sound like. So the magic isn't there. It's just data and statistics on steroids happening with millions of neurons and computing power on the cloud. So yeah, hopefully you've enjoyed that. If you want to learn more about NLP, I did a really fun talk on Wordle and how you can improve your Wordle guesses or your Wordlebot's guesses using The Simpsons and NLP. So you can check that out if you want to learn more there. And hopefully you've learnt that AI has a long history. It's full of statistics. You can ruin the magic for children and hopefully make it more interesting. And you can practice Python along the way. But always remember to be responsible with AI and supervise the risks of both AI and the children who are using it amongst each other. So thank you very much, and hope you grab the resources and talk to me later, because I'm definitely out of time.
Thank you so
Thank you,
much,
Nikki.
Renee. That was fantastic. I love ruining the magic for children.
Yes.
It's what we do.
It's what we're here for.
It's what we're here for.
That's why we came to the education track, really.
It is. I know some of these links have already been pasted in the Discord, and the rest will be pasted in the Discord shortly, possibly by me. And you can catch Renee in the hallway track
Yes.
during the breaks. Thank you very much.